Hi everyone, here is a video about how we can describe and display data. Well, really it's about how to read data that other people have displayed or described, and this is really our first step in being able to read those stats in the results section, starting just with how are they describing their data. So we're going to talk about it in the context as though you were creating it, but the idea is to get the sense, if you know how to create it, then you'll understand why they're displayed the way they are when you go and read it. So the idea here is whatever kind of study you're doing, descriptive, predictive, explanatory, experimental, whatever, you end up just with a bunch of people's responses to questions or answers to tests or whatever it is. You can't just throw up everybody's answer to every question. You have to summarize and describe your data so people who aren't you can understand what your study is doing. So this isn't like how to interpret the stats or to do the stats to answer your research questions. We're going to address that later on. But what this is about is how do we just straight up describe what we found before we look at relationships, before we do comparisons, before statistical tests. Just we measured these things, here's what we found. And so when I say describing data, that's what I mean. It's a way of summarizing what these responses were before any of the tests answer our research questions. Unless, of course, you have a descriptive study and then your research questions are the same as describing your data. But that's a whole other story. When I say displaying data, though, what I mean is how we communicate that to others. So you can describe it and then you go ahead and display it. When we display data, there are really only about 3 ways to do it. First, you can just write it down in text. We found whatever. You could also do a table, which might look like this. For example, this table has no data in it. Or you can do a figure. So whichever one you choose is going to depend on your research question and how you can best express what your numbers are saying. So as we go ahead and try to figure out how to describe and display our data, the first task is to figure out what kind of data we have. Which brings us back to variables. So as we mentioned before, variables are whatever you're measuring, and they fall into 2 broad types. Categorical variables are in categories, and continuous variables exist along a spectrum. Now, as we mentioned before, the main difference here is that categorical variables don't have meaningful gaps between the categories. Within categorical, we have nominal, which you may remember don't have any inherent value to the categories, whereas ordinal scales do have inherent value, but the spaces between them don't really have any meaning. So a person comes in first or second in the race, it doesn't matter how further back you are, you're still in second place as long as nobody comes in before you. So you can't come in like 1.5th place. That's not a thing. The intervals between the categories aren't meaningful. On continuous variables, though, they are meaningful. That's what makes them continuous variables. For both interval and ratio scales, there's an equal measurable space between each point on the continuum. And if you're in between 2 points, then you're between those 2 points. So if you think about temperature, for example, if it's 1 degree out and goes up to 2 degrees, that's a meaningful increase of 1 degree. If it goes up half a degree, that's half a degree. And the difference between 1 and 2 degrees is the same as the difference between 22 and 23 degrees. That's what makes those a continuous scale. Now, the difference between interval and ratio scales is that ratio scales have a true zero, which means that the zero on the scale actually means the absence of whatever is being measured. So looking at temperature again as an example, 0 degrees Celsius is the freezing point of water. But 0 degrees Celsius doesn't mean the absence of heat, it just means the freezing point of water. If you had, say, temperature in Kelvin, 0 actually is the absence of heat. So we would call Kelvin measures of temperature a ratio scale, whereas Celsius degrees of temperature are an interval scale. That difference isn't really super important, though, for now. As long as you've got a handle on continuous versus categorical, that's the piece that's going to dictate the displaying of data and how we describe our data. So when we have categorical data, whether it's nominal or ordinal, there are typically 2 big ways to describe it. Frequency is how many people fall into each category. So it's a straight count. Say you have a split class and there's 15 grade 3s and 12 grade 4s. That's a frequency. It's the number of people in each category. Proportion is what percentage or proportion of people are in each category. So in that same classroom, we'd have 56% of the class is grade 3 and 44% of the class is grade 4. So that's saying out of all the available options, out of all the students, what proportion belongs to each group. Now, which you use is going to depend on what makes the most sense for your particular data and research question. Let's look at an example. I have a bunch of dogs, or I've had a bunch of dogs. Here are pictures of them all. This is our data. Now, what we do with this data depends on our research question. If the question is, how many dogs has Tanya had? Well, we can do a simple frequency count, and the answer would be 7. And then we can go ahead and display that in text relatively simply. Tanya has had 7 dogs. But that's sort of a boring question. Let's say we had a slightly more complicated one, like what breeds of dogs has Tanya had? And so let's start with a frequency count. Tanya has had 3 Dachshunds, 2 Rottweilers, 1 German Shepherd, and 1 Lab. If we wanted to display that frequency data in text, we could, but the text doesn't do a good comparison here. It's sort of confusing to read, or at least it's not the clearest it could be. So let's look at other ways that we could display it. One great way to display counts like this is in a frequency table. In a frequency table, you list the categories in one column, and then you list the number of times that category appears in the data in the other column. So what's nice about a frequency column is that it shows your data in a really clear, meaningful way. So it's a lot easier to look at this and make decisions about what kinds of dogs I like than it is when you're reading the text. You can also pretty easily present this data in a bar graph. The categories go on the x-axis, and the frequencies go up the y-axis. So every bar in the bar graph goes up to the number that corresponds to the number of times each one shows up in the data. Bar graphs are really good when you want to show really clear comparisons, like I've had many more Dachshunds than German Shepherds, for example. So that's frequencies. But the other way we can describe categorical data is proportions or percents. Now, whether you use frequencies or proportions is going to depend on your question and your data. So, for example, in our first example question, how many dogs has Tanya had? That's not a really good good candidate for proportions because there's no whole for 7 to be a part of. You couldn't really say Tanya's had 100% dogs because the next question is 100% of what? Pets? Maybe, but the data doesn't include information about whether I've had any other pets. It only includes information on the dogs I've had. So we can't say I've had 100% dogs. That would inaccurately describe our data. The dogs I've had aren't pieces of a whole, so they can't be reflected in proportions. You can only use proportions when you have a whole that you're breaking down into pieces. Our second question, though, what types of dogs I've had, is actually really easily reflected in proportions. I've had 3 out of my 7 dogs have been Dachshunds. So turning that into a percent, we can pretty easily express that in text. Tanya's had 43% Dachshunds, 29% Rottweilers, and 14% each of Labs and Shepherds. But again, that's not always the best way of expressing it. It's more confusing to read. There's a lot you have to hold in your mind. So let's move on to trying to display it another way. A proportion table looks a lot like a frequency table. You can see here that we've actually imported the same first 2 columns as before. We've just added in one that shows the proportion of the total that is reflected by those frequencies. A couple of important notes here. You don't actually need that column with the frequencies. Sometimes it's nice to include, but it's not necessary. If you just wanted the proportions, that's totally fine. And then the second note is that you can use percent or proportion pretty much interchangeably here. They're not exactly the same thing, but whichever one you think will communicate your results best are the way to go. And as with frequencies, there's a graphing option for proportions. And again, it's the same deal. It's best when you really want to do comparisons about how those individual parts make up the whole. So for proportions, you typically see this as a pie graph rather than a bar graph, although there are some types of bar graphs that can do that. But this is the only time that pie charts are really useful, so it's nice to sort of give them a chance to shine. So to summarize, if you have categorical data, you can describe it through frequency or proportion, and then you can display it through text, tables, or graphs. Now, when it comes to continuous variables, it's a little different. For categorical variables, we could basically choose between 2 different ways of describing data. But for continuous variables, there are three things that we need to use, and we need to use them every single time: shape, central tendency, and variability. Now, these are also a little more complicated than with categorical variables because they have to be, well, calculated and not just counted the way we were doing with frequencies. So let's start with shape. In order to figure out the shape of your data, we actually start in the same place we started in categorical, by calculating the frequencies of each possible score in a data set. So let's say we were measuring temperature again, and we want to describe the shape of the temperature measurement. So we're going to count up the number of times it was 1 degree, and then count up the number of times it was 2 degrees, and the number of times it was 3 degrees, etc. Once we've calculated the frequencies for each point along the continuous scale, we put it in a frequency table, same as we would have done before, and draw a frequency graph. When we had categorical variables, we used bar graphs as our frequency graphs. But here we're going to do the same thing with continuous variables, but we call them histograms. Histograms, as you can see on the top right, look just like bar charts, except there's no spaces between the categories. That's how we reflect that this data is continuous. So these points are all directly related to one another. Now, as an aside, depending on the measure you're using, a lot of times you can't calculate each individual point. There's not enough people at each point. There's not enough points at which it was 1 degree and points at which it was 2 degrees. So you group them into intervals. Essentially, you make them into categories. And you say anytime it was between 0 and 5 degrees, and then when it was between 5 and 10 degrees, and then when it was between 10 and 15, etc., etc., etc. That's totally fine. You're going to follow the exact same policies we're talking about here. Don't worry about any of that. Okay, so then once you have the histogram drawn, you can draw a line over it, like you see in the bottom right here. Or obviously you get your computer to draw a line over it. You don't do that by hand. And then what that line is the shape. That's the line. That line is what we're going to refer to as the shape. That tells you everything you need to know about the shape of your data. Unfortunately, though, that's not actually describing you the shape of your data yet. All we've done so far is figured out what the shape is. So calculating the frequencies, drawing the histogram, then mapping a line onto that aren't describing your data. That's just step one. To describe the shape of your data, you have to actually put into words what that line looks like. And so the first way we use to describe shape is the symmetry. Is it the same on one side and the other? If you drew a vertical line through the middle of your chart, of your histogram chart with the line, would you get a mirror image on each side? That's called symmetry. If your data is not symmetrical, then you would say it either has a positive or negative skew. Now this is sort of confusing because the skew is named based on where the tail goes. So on the left is a positive skew because the tail heads towards a positive direction. Negative skew means that the tail heads towards the negative direction. The next way to describe the shape of your data is the modality. Modality means how many peaks are there on the line. In the left, you can see there's one peak. We call that unimodal. On the right, you can see that there's 2 peaks. We call that bimodal. That's typically, those are the 2 options you get. If you get more than that, we call it multimodal, but your data is really, really compromised if you start getting 3 or 4 peaks. And if there's none, you just call it flat. And then the final way that you would describe the shape of your distribution is the kurtosis. The kurtosis is the peakedness of the distribution. If the peak is really tall and skinny, like the blue one in the picture here, we call that positive kurtosis. If it's evenly distributed, like the pink in the example here, we call it normal. And then if it's flat, like the yellow one, we call that negative kurtosis. Now, if your data is symmetrical, so it has no skew, there's one mode and normal kurtosis, then we actually call it a normal distribution. And that's going to be really important going forward. And this should probably look really familiar to everybody, is the dreaded bell curve. In statistics, though, it's not a big deal. It's just the normal distribution. And it's interesting because when we collect a random sample of scores on just about any variable, our data tend to follow along the normal distribution. That's just one of the magical things about life. We'll talk about more about that when we talk about probability. But in general, the idea of normality is really important. When it comes to displaying shape, you have the same options you usually have. Usually, especially if your shape is normal, then you would just put it in text. The data were normally distributed. And everybody knows what that means because everybody knows what the normal distribution is. You can also do a frequency table. You can present it in a frequency table, same as we saw before. Or you might present the actual histogram if you need to. Now, typically you'd only use one of those options if you had really complicated data, if it was not normal in a really specific way, or in a variety of ways. If it's not normal in only one way, then you would probably still just put that in text. Say, oh, this data had a positive skew, or this data had positive kurtosis, or whatever. So the next way we have to describe continuous variables is central tendency. Central tendency is a statistical measure that identifies a single score as being representative of an entire distribution. So we're looking for the single score that is most typical or most representative of the entire group. And there are three ways you can do this: the mean or average, the median, or the middle score, and the mode, or the most common score. Your reading this week actually has really detailed explanations for calculating these, so I won't go into it. I'm sure you're all at least familiar with means, and the other ones aren't really too hard to grasp. But the important point is, for every continuous variable you have, you should be reporting at least one measure of central tendency. You don't need to report them all, but you should be reporting one. In general, for most continuous variables in education, we report the mean. Only very, very rarely do you see a median score, and basically no one reports the mode. A friend of mine, when I told her I was making this video, literally said, make sure you tell them the mode is useless. Which isn't 100% true, but it's true enough that I laughed and then repeated the joke just now. When we go to display central tendency, you do it the exact same way we did with continuous variables. You can put it in text, the average score was whatever. You can put it in a table, or you can put it in a bar graph. When you only have one thing you're measuring, you typically go with a text, but if you have more than one, if you've taken a lot of measures and you want to show the average of all of them, then tables and graphs are typically a better option. You can also use these same display methods for median and mode, but again, 99% of the time it's mean. Now, I'm showing you these as examples, but there's actually a big flaw in all of these displays. And that is that no display of central tendency is complete without a display of variability. Variability is a measure of how well varied your data is. If central tendency is one number that best describes your data, variability is one number that tells us how spread out that data is, how much variety is going into that central tendency score. Typically, variability is measured in two ways, both of which are based around measuring how much variability there is around the mean. So variability as a score is really focused on the mean. The first one is variance, which is the square difference of each score from the mean, and then the standard deviation, which is the square root of the variance. Nearly 100% of the time, you'll see standard deviation. You'll only see variance when you're doing a particular statistic, or some particular statistics. We'll get into that later when we talk about different kinds of statistics. In terms of displaying variability, mean and standard deviation are buddies, which means you should never be reporting the mean without the standard deviation, or one without the other anyway. So when displaying variability, we just take all the different ways we displayed mean and then add standard deviation to it. In text, that means you have to say both. The average score in the test was 80 with a standard deviation of 5. In a table, you put them both in, and the way you often see that is you'll put the standard deviation in parentheses next to the mean. And then in a graph, the way you do that is you put a little error bar on top of the graph, and that's the standard deviation. A really small note here, you'll typically only see that little bar above the graph, but you need to imagine it below also. So it's basically flipped over from where it is. And again, when you only have one thing you're measuring, you typically go with text. But if you have more than one, tables and graphs are typically the better option. Okay, then to summarize so far, we have categorical variables, which we can display as frequencies or proportions. We have continuous variables, for which we have to put the shape, which we typically do in text, and then the central tendency and variability, which always go together and can be expressed in a variety of ways. And that's going to cover you for most of the studies we're going to look at. But for experiments, we have to do something special because they think they're so special. And what that basically means is for experiments, we're not that interested in the overall mean or the overall shape of the dependent variable. What we're interested in is how that dependent variable might be different in different categories. So for an experiment, we typically have one categorical independent variable or more, but for now we're just going to say one, and then a continuous dependent variable. And so we're not interested in how many people are in each category. That's not helpful, especially if we randomly assigned it. It'll be equal. And we're not that interested in the overall mean. We're interested in the mean in each category. And the good news is that's actually really simple to do. We just calculate separate means, standard deviations, and shape for each group that we have in our experimental data. So if we are interested in the effect of an intervention and we have a treatment and control group on test scores as our dependent variable, then we're going to want to know the test scores for the control group and the test scores for the treatment group. And we're going to want to know the shape, central tendency, and variability of each of those control and treatment groups. And then to display it, it's the same deal again. For shape, you probably would put this in text, but for the rest of it, you can see it's actually pretty awkward in text. The mean score for PVT for the lower income group was 88.73 with a standard deviation of 11.29. No, that's too much. With the exception of shape, which yes, you will likely put in text, but when it comes to the mean and standard deviation, you're going to want to put that in a table or a figure. Here's what the table looks like. You have the dependent variable listed in the first column, and then in the next column you have one of the categories, and then in the final column the other category. And again, we see here again means and SDs together. They're buddies. And then you could also do them as graphs. Again, it's the same deal as we saw before, we just have more than one bar, and in this case the bars are directly related. Okay, and then just to wrap up, let's just have a couple of tips. First, for figures, start intervals at 0. Make sure that the base at the x-axis, your y-axis, and your x-axis both start at 0. Well, your x-axis is usually categories, but your y-axis, make sure it starts at 0. Excel, sometimes if you're making graphs in there, we'll try and get them to start at 3 or whatever point makes your data look more interesting. Don't do it. And then you also want to make sure that you're using equal interval sizes. If you have multiple graphs, if they're on the same measurement scale, you want to make sure that the intervals are the same across all your graphs. And then finally, look up the APA formatting for tables and figures. So for both of those, APA is actually really precise in what they need. So you should look it up and make sure you're accurate there. And then finally, and this is really a big one, and for figures specifically, don't use 3D graphics. They're terrible. Don't do it. They don't make it look nice. They make it harder to read. It's Flash for the sake of Flash. Don't do it. Just trust me on this one. Okay, so that's it, everybody. Thank you so much, and have a great week.